students, welcome once again to another section. And this time we have an equation over here, so we have to find the possible values of a, right? Okay, so let's do that. So we have a to the power 4, then so let's group like terms. So we have positive 10a squared, right? Then negative a here, then plus 30 here being equal to 0, right? Now what we're going to do next is to write this so that we can get a perfect square over here. So when you have just a to the power 4 plus 10a squared, then plus 25 here. This is just a plus 25, so a squared plus 5 all squared, right? So that would be a perfect square. So how do we write this in the form of that? So we have a4 plus 10 a to the power that. Now remember we have 30 here, right? So we can write this 30 here as just 25 here, right? And we can have negative a plus just 5, right? So when we add 25 plus 5, we still get the 30 and the minus a equals to 0. So all of this will just be that a squared being equal to, let's send this to the other side, so it's going to be a then minus 5 here, right? Okay, now remember we have to find the possible values of a, right? Okay, so let's apply root to both sides. So we apply roots. So applying root, we have a squared plus 5 here, all squared. So we apply root here, and then also we apply root here, right? This will get rid of that, and we have just a squared plus 5 being equal to a minus 5, right? Now let's see this equation over here. Now this equation here is just the inverse of this equation over here. Now what am I trying to say? So let's set a variable. So let's say y here is equal to remember there is a square root of a minus 5, right? So when we square both sides, we have y squared being equal to a minus 5, and from here let's make a the subject. So a here will be equal to just y squared here plus 5, right? So you realize that these look a bit right, so kind of looks similar. Now if you look at this equation over here also, we have a squared plus 5, and remember square root of a minus 5 we said is equal to y, right? So that one should also be equal to y. Now we have a here, so let's call this equation 1 and let's call this equation 2, right? So let's put them in a system of equation. So we can have yes, a here being equal to y squared plus 1, right? And then also we can have y here being equal to a squared plus 5. So let's call this 1 and let's call this 2. And let's solve this simultaneously. So what we have is a symmetric system of equations. So what we are going to do is to substitute one into the other. So we substitute equation 1 all right. So let's rather subtract equation 1 and then 2. So subtracting equation 1 and 2, we have a minus y here being equal to y squared minus a squared. Then we have 5 minus 5 here. So we're going to get a minus y here being equal to y squared minus a squared. So let's send this to the other side. So we have a minus y here, then sending this to this side, we have plus a squared and minus y squared being equal to 0. Now what we are going to do is we are going to group like terms. You realize that in each case we have a minus y, right? We have a minus y something like this. So we can bring a minus y outside. Now what we are left with is 1 here, and we are left with just plus a plus y being equal to 0. Now when we expand this, when we expand the whole of this, we should get that, right? Because a minus y will just give us that. Then a minus y multiplying a plus y is just a squared minus y squared, right? Okay, so we have this here, a minus y here, being equal to 0, and therefore a is basically equal to y. If that is the case, then we also have, so let's say we're going to put a equal to y here into the second equation, right? So equation 2, we had equation 2 here as y equal to a squared plus y plus 5. So y here being equal to a squared plus 5 here. Then we have y here being equal to just, so y is just a, so we have a, we have a here being equal to a squared plus just 5, right? Let's write this for, so we have a squared minus here a, then also so we have plus 5. So let's solve this being equal to 0. So let's solve this here. So when we apply the the quadratic formula, you realize that just y being equal to that, then we have b squared minus 4ac over 2a, right? So when we substitute the whole of that into it, we are just going to get a here being equal to 1 over 2, then plus or minus square root of 19, also divided by 2, imaginary. Now this is a quartic equation. You realize that it was s to the power 4 from the beginning. It's a quartic equation. Normally quartic equation has they are imaginary values, right? So we have a being equal to that. Now for the second part, where we said that so what we did here was to substitute this into the second equation, right? So let's substitute the other one into the second part here. So we have this, right, being equal to 0. So let's do that. So we have 1 plus a plus y here being equal to 0, right? So if in this case also a equal to y, right? If a equal to y, so if a equal to y, in this case y here is just equal to a plus 5, right, from equation 2, then which means that we have that, and we can substitute the whole of this into this equation over here. So we can have a squared plus 5 here being equal to 0. So we have a squared here, then we have plus 5 here, then plus 6 being equal to 0. When we apply the quadratic formula, then a here should be equal to this negative half here plus or minus square root of 23 here, right, divided by 2 here, then imaginary. So we have imaginary in both cases. As I said, quartic equations are imaginary values. So we have these, and then also we can have the first equation we had was this root 19 here, divided by 2, the imaginary. So these two equations are what we add. So that's the values of a, the possible values of a. Thank you very much for joining me in this section, and I will see you in another section.